Hey everyone.
Hey.
Hello, hello.
Alrighty, I think
We have to do this webinar for real because I'm having fun just like hanging out in the chat. Can I just keep doing that? Maybe we'll just do that for the next hour.
we got plenty of time to chat at the end. We got a little
Okay, all
bit
right.
here for first, and then plenty of chatting at the end.
Okay, if I miss my slide cues, make sure to yell at me because I'm too attached to the chat.
All right. Well, they'll tell you in the chat, and then you'll know it's time to
Tristan, it's your turn.
Time to keep going. Alrighty. So I want to say hello and welcome everyone to today's virtual event, which is all about accelerating DBT with SDF. We've got some great stuff to talk to you about today. As you may have heard, DBT Labs has acquired SDF Labs. SDF Labs has built incredible technology for data practitioners, and we've been fans of theirs for a while. And today, you're going to get to meet Lukas from the SDF team. We're going to talk about what this means for DBT, for data practitioners, and we're going to answer some of your questions about all of this. And so with that, I am your humble host, Jason Gans. I am the Senior Manager of Developer Experience here at DBT Labs, and you are mostly today going to be hearing from Tristan Handy, founder and CEO at DBT Labs, and Lukas Schulte, previously co-founder and CEO of DBT Labs, and now director of SDF Labs. A lot of labs here. We got too many labs.
Far too many.
And currently director of engineering at DBT Labs. Quick note on agenda. First, Tristan is going to walk us through some high-level context on all of this, why it's interesting, why it matters to you. Then we'll pass it off to Lukas, who's going to tell us a bit about SDF, give us a quick demo, and walk us through it. And then we will wrap up and have plenty of time, hopefully, for Q&A with all of you. And with that, Tristan, off to you.
All right, let's do it. And I'm pretty confident that at some point my dog walker is going to come in here and take my dog. So we'll just roll with it. This is a wonderful photo. This is the four wonderful co-founders of SDF Labs. There are clearly two people who really like to do serious face in group photos, and two people who have like really good smiles. Two of them are father and son, and I will let you guess which those two are. And at the end of this, when we have time for Q&A, you should definitely ask Lukas what it is like to found a company with your father. We've had many interesting chats about that. But this group of humans is super wonderful. You get to meet Lukas today, but I'm sure that Michael, Wolfram, and Elias will make themselves known to the wider DBT community as well. So wonderful folks, super happy to have them on the team. It may in many contexts when there's an acquisition, it's all about the product, and the product here is incredible, and Lukas is actually going to give you a demo in a minute. But this team is truly incredible. There are 16 folks that joined DBT Labs from SDF, and they are like really incredible human beings. Some of the most knowledgeable people in the world on compilers and on databases. You can read this list. Lukas can't brag about this stuff because he's too humble. So I have to brag about his team a little bit. The one thing that I want to maybe tell a little bit of a story about is the one on the bottom right of this list. Wolfram, who was the CTO at SDF, was after a long career at Microsoft Research, doing a bunch of compiler-related stuff, was actually hired at Meta to run an effort in the wake of, I don't know how many folks remember all the stuff that went on with Cambridge Analytica in the 2015, 16 time period. But there was a lot of the PII was a very big deal, and it became very important very quickly for the entire company, massive global company, to really get a handle on its PII and how it traveled through the organization. And so Wolfram led the effort to build the SQL parsing that made sure that every single data pipeline at Meta could track all of the PII that flowed through the company. And it was really this kind of this project and all of the learnings and research that came out of it that the team later put into SDF. And so it is not, me and Drew and Connor have background as data practitioners and kind of hackers. We did a thing that worked for a tremendous number of people because we really understood the analytics engineering workflow, and the SDF team has a very different DNA. They have built serious technology at the world's biggest companies. So we're happy for these two kind of DNAs to fuse together. I want to be super clear about one thing. SDF is the future of the DBT engine. Now, DBT does a lot of stuff, and when I say the engine, what I really mean is the thing that translates the SQL code that you author, SQL plus Jinja code that you author, into actual transformations that execute against a data platform. The SDF brings faster performance, optimized data platform costs, better lineage, and over time it will bring even more. And one of the most important things about the way that this will manifest itself to everyone here is that you don't need to change the code in your DBT project to get these benefits. This is not an easy feat to accomplish. The Jinja is at the heart of DBT. It powers a tremendous amount of the functionality in DBT, and it's what makes sure that regardless of what you need to accomplish with DBT, you can always make sure that you can accomplish it. And having that confidence is super important when you initially bring the project in, because you know that you're never going to hit a dead end where you're like, well, crap, I can't do it. But Jinja is also really hard to work around in contexts where you really need a tremendous amount of performance, whether you need when you need to understand the SQL that is being written. All of these things become hard when you put Jinja in the middle of your project. And so that is one of the things that I was the most excited about when meeting Lukas and Wolfram and the rest of the team, is that they've really taken as the first principle that all of the DBT users in the world who have learned to write DBT code and all of the DBT code that exists in the world need to operate in a first-class way with an upgraded engine. And with that, Lukas, why don't you take it away?
Yeah. First off, hello, everybody. Great to meet you all. I'm really excited to be here and talk a little bit about SDF in particular. So today, a lot of the stuff that we're going to be seeing is just SDF pre-integration. It's like the giant asterisk that is very important to say. But maybe before we dive into SDF, I can share a little bit about like the DBT developer experience as it is today and what we wanted to change about it. So DBT is a fantastic configuration tool and scheduler once the DAG is specified, but you have to manually specify the DAG with ref statements. And DBT as an engine understands the SQL that you write more as a series of strings. And then it expands some Jinja, makes the strings longer or shorter, or changes them in some way, and then sends them to a data warehouse. And it's only at that data warehouse stage that you actually get validation of whether or not that SQL query was correct, right? So dbt takes a raw query. There's some pre-processing that happens. That's that purple arrow. Then there's a question of, is this a valid query? dbt has no way to validate this at the moment. We send that to the cloud data warehouse. The cloud data warehouse uses its compiler to compile and run and validate that the statement is correct. And then the cloud data warehouse sends back the error and dbt passes it back to you. So this works, but it means that you always have this overhead of talking to a data warehouse before you get any feedback on whether or not something is correct. And if you compare this to other software systems, especially, there you can typically run everything locally, right? The compiler for C++ validates the project without you ever having to run it on AWS. The same goes for Python and Rust and a whole bunch of other programming languages. It's really only SQL where you have all these different dialects that makes it really hard for tools like dbt to introspect and understand what is happening in the SQL before it's sent to the runtime, the compute engine. So this is sort of a fundamental limitation of data tooling today, and it's exactly the thing that we wanted to address at SDF. So let me pop to the next slide. Now we can talk about what changes with SDF.
Hey, Lukas, can I interject a question real quick? You were talking about dialects. Is this always been true? Like, since the very beginning of relational databases, have there always been wars over SQL dialects between, or was there a wonderful Garden of Eden where we all kind of agreed on SQL dialects?
Okay, this is a great question.
Sorry,
one that I think is like,
you off script.
Yeah, it hasn't been discussed that much, right? Because it is different, right? Like .py, like that's a Python file, right? There's not like 5 different companies that have different versions of what a Python file looks like. So SQL is I think part of it is technological and part of it is vendor driven. The technological piece is SQL doesn't have a good way to create abstractions like libraries, right? There's no import statement in SQL. You just declare what you want your table to be. And that means that it's very difficult to build newer and different abstractions. So if you're a vendor, on the one hand, maybe there's not a really great software ecosystem that builds. On the other hand, you can say, hey, we're going to build our own custom attachments to the language because we need to extend the language in some way, right? We want to do special purpose things and call AI models and create different data types. So the technology was a little bit limited in the sense that SQL doesn't have libraries, but then vendors, I think, also took advantage of that to create this sort of more locked-in ecosystem where dialects are very not compatible with each other. There is officially an ANSI standard, but the ANSI standard is only, let's call it, loosely supported by, I think, a lot of the different data warehouses. So yeah, so then 30 years of this, right, where SQL is still a dominant language, means that for 30 years vendors have been able to slowly differentiate and create different structures and types and functions that only are compatible with their SQL dialect. It's a long-winded answer, but hopefully that.
Thank you.
I love this slide from the chat. We don't even use the same SQL dialect at all parts of our company. It's just, we see it all the time. It's just like people are out here, they're using all different kinds of SQL.
Yeah, exactly. And this is like, it's kind of a shame. Like I can go down this rabbit hole for a long time because we spent a lot of time on it, but it is kind of a shame because typically software is portable, right? Like you don't have to reinvent the wheel. The beauty of libraries and software is that you build one thing, then you build another thing on top, then another thing on top. But with SQL, like anybody who writes a model for what a daily active user looks like is writing it from scratch, right? There's no libraries or abstractions to take advantage of. Anyways, I digress. Back to SDF. So SDF, we wanted to change this a little bit, right? Exactly this, hey, there's no real good local development experience. There's nothing locally that truly understands SQL at a very, very deep level that is out there in the public at the moment. So what did we do? We partially built out and defined what the grammars look like for different SQL dialects in different data warehouses. So we have a different grammar for Snowflake that is equivalent to the grammar that Snowflake itself uses, one for Redshift, and on and on and on. BigQuery, Databricks, like the major ones. And once you have the grammar and you understand what the type coercions are for Snowflake and the different functions and the parameters that those functions take, you can actually build something that looks very much like the Snowflake compiler itself, the Databricks compiler, Redshift compiler, etc. And when you have that compiler, you can actually cut out this call to the remote database because you can validate the SQL directly on your local box. So with SDF, when you have a query, we don't just do this pre-processing step of resolving Jinja. We actually compile and validate the SQL query before it ever gets to the data warehouse. And that means that if there's an error, a syntactic error, a semantic error, you're calling the wrong function, you're depending on a table that doesn't exist, you get that error much, much, much quicker in the development cycle. And I think it makes for a much more sort of software-like experience that I think if you're coming from a world of software engineering, you kind of expect. There's a lot more to dig into. We spent maybe close to 2 years incubating the technology and really making sure that the compiler, the dialect correctness, et cetera, was really there and production ready. And maybe the last thing to sort of point out is this system in Python would be very slow, but we had the fortune of starting the development in Rust, which I think anybody that builds anything in Rust has to say that. And as a result, we were able to take advantage of a lot of the performance benefits that we get there, so that this system does actually run and is very performant even on your laptop. Great. Looking forward to questions about all this stuff, but let me move on. So I think it's time for my favorite part, which is, can we show this stuff live? Yes. I'm going to stop sharing here. Stop sharing the slides here, and then I'll start sharing the screen. All right. There's nothing better than live demos.
Let's go.
Let's go. All right. So congratulations. We're looking at some code this morning. What you see here is VS Code window with a tiny data warehouse. And that tiny data warehouse is described in SDF's configuration language, which is this sdf.yaml. And again, I want to point out this is SDF. This is not DBT. We're going to show SDF today. The goal over the next months is to integrate a lot of the core technology back into DBT, and I'm super excited how well that's going. But for today, we really wanted to show all the cool stuff that we built in SDF. So you'll notice I'm not in a virtual environment here, and that's because SDF is a Rust application. That means it's a single binary. You can deploy it however you want. It doesn't need a virtual environment. It's quite small. The resulting binary is like less than, I think compressed is about 50 or 60 megabytes. That makes deployment super easy on Docker containers and CI machines, etc. And I don't know about you, but I'm not. I really don't like dealing with mismatches in Python versions and libraries and so on and so forth. So it's kind of nice that this is just a single binary that you can deploy. So you'll see that a lot of the commands are the same here as what DBT has, right? There's compile, there's run, there's test, but there's some more, and we'll get into what those other ones are. The workspace itself is relatively straightforward. We are defining a workspace. We have an addition. We're including some stuff, some models, some macros, some checks. We have some dependencies. We have an environment. We're talking to Snowflake today. And you know what? Let's see what happens when we compile. Because it's not quite what DBT does. All right, let's look at this output and try and parse this output. So we compiled the project. Everything is green. took a second and a half. And I hope that this is the longest command that you'll ever see in this demo today. First, we downloaded some schemas. Why did we download schemas? There's this very, very difficult problem with building data warehouses, which is that the data warehouse has a state and tables and schemas, and your code has a state and some queries, which represent schemas. And today, there's nothing that can stitch those two states together and make sure that your code state and your database state are always in sync. SDF does this. So first, it goes through the code, finds references that are not there, and will pull them directly from the database so that we can compare all of the compiled models in relation to the database state that we downloaded here. This works even at very, very large scale. All we're doing is downloading some schemas, right? So it's just some small little JSON objects. But it means that we can now validate that any model downstream actually works in relation to what is true in the database at this moment. And this is a really fundamental difference, I think, to how SDF works compared to DBT, because we really try to guarantee that the state is always correct. And when the state is always correct, that means that pipelines tend to not break because there's no issues with schema differences. It means that development is a little bit faster because you catch bugs and issues with state on your machine as you're developing rather than when you're deploying it or in CI. We found that it's actually a crucial piece for improving the developer experience here. All right, this was maybe slightly long-winded, but I think it's a really, really important point. So we compiled, everything works. Let's break some stuff. Let's be a little bit of chaos monkey and see what we can break. So we're going to go to daily orders here.
Lukas, let me interject real quick. There's a question that I want to get to in real time.
Sure.
Somebody asked, will DBT compile be made obsolete in favor of a form of SDF compile? We can get into the kind of underlying tech over the course of the rest of the conversation. I just want to, my understanding, and please correct me if I'm wrong here, is that we're not actually going to be asking users to change any of the DBT commands that they use. We're bringing SDF tech into the product, and we're not going to ask people to actually change their command structure. True statement?
Yes. That's okay. I think that's absolutely correct. I think it's really important. The worst thing as an engineer is to have the sand shift underneath your feet. So things that worked yesterday have to work tomorrow. If you want to opt into other features, I think that's exactly what we're working on now, how to make that available in a way that feels really seamless. But the goal is there are no shifting sands underneath your feet if you're an engineer working with DBT today. Yes, great question. Super, super important to call out.
Thank you.
Nice. Okay. So we have a SQL query here, daily orders. It's not the most interesting SQL query, but here's a demo for you. Let's break some stuff. Let's do something really simple. Let's make a column reference that doesn't exist. Notice also here there are no ref statements. Ref statements do work. We just don't necessarily need them. So we're just selecting from orders here, and orders is resolved by the configuration that we did in the workspace. So let's compile this. And in less than half a second, we get this nice error. No column order stat found. Here's the available columns, and SDF will always give you a resolved error. So if you go to any other file or you happen to be working in a workspace, you can always click on the error and be taken exactly to where the error is in your workspace. And this works even through Jinja as well. So SDF resolves Jinja and macro spans in the same way that it resolves code. And I know how annoying it is to have an error on line 80 when 80 is the resolved Jinja, but you're actually editing a file where it's on line 42. So in SDF, that should never be a problem, and that's definitely something we're looking to take to DBT. So let's fix this. and create and make sure that we can compile. Great, compile again, less than half a second. Let's do something different. Here's an interesting one. So group by 1 instead of 1 and 2. Again, I think this should fail, right? We have a bunch of SQL heads in the house. Let's compile. Let's see what the compiler says. Compiler says, hey, no, we have unaggregated columns in an aggregation context. Again, in less than half a second. None of these calls are going to the database. It's the compiler resolving these errors locally on my machine. So no matter what I do, I can create SQL expressions and fix them in real time. So we'll fix it, compile, success. Great. Let's do something weird. What happens if we what happens if we cast order place date as a big int? Does anybody know if this works? I actually don't. We're doing it live. Let's compile. And turns out you can't because you can't cast date 32 to a decimal 128.38.0. And again, we have this nice error that takes us exactly to the line in the column where that error is. So let's fix it, compile, success. Again, less than half a second. I think so far there's been no fibbing going on. Everything that you see, I think should take less than half a second today. And this is the case for, even much, much, much larger warehouses than the little one that I'm showing you today. So this is great. But what other metadata does the compiler know? Turns out a lot. We can compile and we can show all. And you'll see that the compiler knows all the column names, but it also knows all the data types. And then it also knows about classifiers and descriptions, and it propagates descriptions when possible. But again, having that deep understanding of exactly all the table schemas at your fingertips without going to any other system is really important as a developer. Cool. Let's move on. This isn't even all the metadata. Let's find more metadata. Let's look at lineage. So SDF does lineage a little bit differently. It does it as part of the compilation step. So we're going to say, hey, SDF, give me the lineage for this table and this particular column, number of orders shipped, which is, I believe, this one. And as part of the compiling process, we have to resolve dependencies, and resolving dependencies gives us column of lineage. And crucially, you'll see that the column of lineage also has little tags around mod and copy, and scan is another one. What are mod, copy, and scan? The compiler knows that the columns have been modified, right, through a function application, right? In this case, we have count and a when in here, whereas a copy from signifies that you're just copying, right, with maybe a filter expression. So the compiler understands the different types of lineage that are happening on each column, including that this lineage exists. Hopefully very cool, very valuable when you're looking at PII and how PII changes and moves throughout a warehouse. So this is something that I think from a governance and privacy management standpoint is actually very, very powerful. Awesome. And now let's do a run. Cool. Just like DBT, you can run models. We are, again, downloading the schema, validating to make sure that even at runtime, everything is correct. And now we've ran all of our models. This is cool. This looks a lot like DBT. But let me go to a particular, some other model here, like orders.sql. Orders.sql is pretty straightforward. I have no idea where it is in the DAG, but we're going to do, create like some new change, right? So we have a DAG. We made a change on a single SQL file. What happens if we run again? It turns out that as part of as part of the metadata management, SDF keeps state. So while our previous run, we had 12 models and we ran all of them, 12 succeeded. After our change, that same run, the engine took care of resolving dependencies, finding out what changed, finding out what metadata changed, what data changed, and then only ran 2 models, orders and daily orders, because daily orders depends on orders. So you have included automatic state management as part of this whole system as well. And again, it's because SDF generates a lot of metadata, captures column of lineage, captures state about code, captures state about the data warehouse, and then uses that to optimally calculate and recalculate what needs to be run at any given point in time. This is awesome. It's wild from a cost savings perspective what this can do for a data warehouse, and something that we're super excited to bring into DBT. I think I've been talking for a while. Gans, Tristan, any questions, anything you want to ask here?
I've been trying not to interject. There was somebody who was shit-talking you for using 2 spaces for your tabs. He said that it's out.
Okay,
no longer
that's
going to use the product.
I've just been enjoying the chat lighting up. People are there are some complaints that now people aren't going to be able to go and get a coffee or check the DBT Slack because it's just going to be too fast now. So I think that we're going to have to add in some kind of like optional breaks for people because we're just making it so much faster now.
Okay, I think that's okay. I'll try and keep this demo fast as well. I think there's one other piece that I really wanted to show, which is all the stuff that you can do around data classification when you have this metadata. So I think one of the really unique contributions that SDF made to sort of the transformation space was building in a native data classification layer. So data classification, for those of you that don't know, is adding additional metadata fields to columns, tables, etc., so that you can keep better track of what type of data is going where. If you're tracking PII, like a social security number, a credit card, this becomes very, very important. And at the same time, it's been very difficult to actually build an automated system that does this for your whole data warehouse. Instead, you kind of have to tag every column manually all the time and update it as the warehouse is changing. It's a nightmare. It's not fun. I've spent some time manually tagging things. It's terrible. So in SDF, there's a very neat way to create classifiers, right? Like we're defining one here. We're saying, hey, we have some classifier PII, and there's name and phone and email and an address. And then we also have hashed. And then we have this metadata being added to a single table, right? So just raw customers, we are adding this metadata to, right? We're saying that raw customers, the column name is sensitive and it has some PII.name, email has some PII.email, etc. But then we're also telling the system that the function MD5 converts any PII, PII.star, to PII.hashed. Okay, why is this cool? Data changes as it flows through the warehouse, right? Functions are applied, you aggregate some stuff. So you can't just propagate PII downstream along column level lineage. You have to understand how functions change that PII. And you can define this relatively simply and then take advantage of an integrated information flow theory engine that actually does the propagation for you downstream. So let's see what this looks like. We're going to do SDF compile once again, show all, and I'm going to scroll up a little bit to some stuff we didn't see before. So here's all of our tables. And at the very top, somewhere here, we have raw customers, which is exactly the table that we added some metadata to here, right? Raw customers has these classifiers. These are exactly the ones that we added here. Name has PI.name, email PI.email, etc. But if you scroll down a little bit, you'll see that CRM customers also has this PII. And somewhere down here, big customers has some PII.hashed and some PII. So natively, what the engine is doing is actually working with higher level types in addition to the varchars and the ints that the SQL engine is working it with to propagate those types through the warehouse. So you only have to classify things at ingestion, and then you automatically get full coverage across the data warehouse. It's incredible. I don't know how many of you are working with slightly larger DBT projects, like hundreds of models or even thousands. Being able to, if you're working at that scale, you're probably dealing with thousands or tens of thousands of hundreds of thousands of columns. Being able to automatically manage how different types of sensitive information flows through that is incredible. You can use it for retention capture, right? This data should be captured for 3 years, for 7 years, etc. For defining metrics and daily active users, canonical metrics for things. It's actually a very, very powerful system, and it's something that we're really, really excited to bring to DBT. Nice. Cool. Last thing, and I will make this demo super quick. There is also a built-in lint command. So this linter works differently than SQL Fluff. It operates on the concrete syntax tree that is generated by the parser. Because of that, it's quite fast because there's just this whole series of tree walking algorithms that happen. You can run SDF lint, and the linter will, again, in 0.4 seconds, show you all of the areas where you have some issue. Here, we're saying that keywords are expected to be consistent. It always gives you, again, the where things are not consistent. Here you have capital with, here you have a lowercase from, and you can lint -- fix. And now in 0.4 seconds, once again, we've resolved all the linting issues. You can see them in my code, in my Git control here. That's it. I think I said at the beginning that nothing here should take more time than the first command that talked to the database. And I think that's still true. Every other command that I showed was less than half a second. And again, this is exactly the kind of speed that we want to bring to DBT and the type of structure we want to bring to DBT, and what we're really excited to be working on for the next months as we go through this integration process. So again, this was SDF. This was not DBT. Hopefully we can show a lot of really cool stuff and how we're bringing this into DBT the next time that we do this. I will stop sharing my now, and we can continue. Great. Thanks a lot. I think there's a couple more slides where we can get into some technicalities. Let's do that, maybe.
Yeah, how does this all work? It's very impressive. What's going on under the hood, Lucas?
What's going on? A lot. Dan's like, a lot of stuff is going on under the hood. Let's talk about some of it. So let's talk about the different types of SQL comprehension. There is a really, really great post that Jason and the team put together to sort of break down the levels of the compiler and the different things that it understands. And we're going to start with just a really nice, simple SQL statement saying, hey, we're going to select, we're going to add a day to day, and that's going to be the new day. Nice. If you look at how a parser, like if you just have a naive parser, how that understands SQL, you get some stuff, but you don't get a ton of stuff. Also, I have to call this out. Did you choose SDF because the letters are next to each other on the keyboard? Yes. We figured it was the best series of characters for a command line tool ever, and I stand by that. I'm sorry, DBT, but I have to say from a typing CLI, this is it's the best. Where was I? So yeah, having a parser.
Hey Lucas, do you want to call an audible real quick? I don't know if you've been following this while you've been talking, but there's like 1 bajillion questions, and I know we wanted to save time for them, but I wonder if we wanted to actually skip through some of this content because it's been written up, and maybe we could just share some links. How do you feel about that?
Sure. Yeah, that's totally fine. And if the slides are helpful in answering some of those questions, we can hop back to the slides. That sounds great.
Yeah. Okay, cool. Because this is, I love all the engagement and want to make sure that we get to that stuff. Let me, so one of the biggest questions that keeps coming up, and let me just hit it in slide form. Will I get access to this? So my guess is that there's a bunch of folks on here that are dbt Cloud users, but there's probably even more that are dbt Core users, and that's great. The statement that I made in my blog post was that we want to give a bunch of the SDF functionality to users of dbt Core. But at least at the outset, and there probably in the fullness of time, there will be trickling from proprietary SDF technology into dbt Core, but that will probably happen in some down the road time period. For now, what we're doing is we're finding ways to give Core users access to the power of SDF without needing to make all this open source. I know that there's open source versus proprietary can be a topic that is gets into kind of almost pseudo-religious territory. But Lukas, I want to ask you a quick question. Did we have to pay you some consideration for the acquisition of SDF, the technology and the team?
Yes.
Yeah. So there was money involved in this. We unfortunately had to pay to acquire the company, and so we do actually need to create some monetization mechanisms here. We're a business and trying to make the business work. Sorry, Lukas, I should have prepared you for that question ahead of time.
No, I was wondering if this was like a trick question.
No, it's not a trick question. So yeah, there is going to be stuff that's in cloud only, but truly the developer experience stuff, we want Core users to be able to use as much of that as possible. We have some ideas on how we're going to make that happen. The teams just started working together, I don't know, 4 weeks ago, something like that, maybe 3 weeks ago. So we're not ready to share quite yet. The big reveal in terms of like how that part is going to happen on our spring product launch, which is on March 19th.
19th.
So we'll have, say it again.
Yes, 19th, that's correct.
19th, okay, great. So we're gonna have actual like integrated product experiences demoed there and be ready to talk more specifically about that. But the statement is that absolutely Core users will get a bunch of new functionality out of this, and will continue to get new functionality over time. But as always, we want the premium experiences to be inside of dbt Cloud, because guess what? We have to pay a bunch of really smart people to write a bunch of code. So let me see if, yeah, okay, we covered that. Let's get into the Q&A. Should we stop sharing and we can get over there? Jason, you want to run it?
Yeah, let's do it. Okay, so I need everyone to know, before we went live, I was like, what do we do if like there aren't enough questions? And then we have just such a tremendous number of questions here. We probably have hours and hours worth of conversation about all of these things, and so we're going to get to as many questions as we can today. But I expect us to be having these conversations again and again over the coming weeks, months, years. So with that. Lukas, there were a lot of questions about types and what it means for your system to be aware of types. I want to pull out this one from Katie, but then maybe we can talk just like a bit more generally about type awareness and what that gets us. So the specific question is, when the compiler throws an error related to data types, is it getting the type from the schema.yaml or the database? How does SDF know about types?
That's a great question. The schema.yaml, let me put it this way. SDF prefers things in code, and if things are not defined in code, it will go and pull them from the database. This is really important because I think, DBT started this, 8 years ago, and I think it's the way in software engineering everywhere. Systems are typically code first, right? You define things in Terraform and then you apply them in the cloud. And SDF works in a similar way. You prefer defining things in code, and things that are not defined in code because they're some external database or table, it will import for you automatically. And that's it.
Great. Super helpful. All right, let's keep going. Next up, I'm trying to find the actual question because there were a bunch here. But there was a question. It was asking how SDF compares to some of the other technology in the field. There's a question around SQL Mesh, and I know that Lukas gave some thoughts around SQL Mesh and SQL Collide. Oh, it looks like Tristan might be ready to jump in.
I hate public comparisons between products. There's a lot of smart people who are trying to build great stuff, and I have never want to be critical of stuff that other folks are building. I will say that we over the last several years have been tracking an entire. Actually, you know what? I'll call out Pedram Naveed, who wrote a blog post. Gosh, Jason, was it like all the way back in 22?
22, yeah.
Yeah, called something like "We Need to Talk About DBT," something like that. And he was the first one who I think like really publicly was like, "Look, we need some developer experience improvements in DBT." And so I honestly have been tracking this conversation like very, very closely ever since then. And there's some different people who have taken different shots on goal here. And I fully admit that we have been waiting for a solution that we felt was actually the correct long-term solution. And we don't feel like that solution had arisen until the SDF announcement post on June 27th or whatever it was. And so I had been, I am very confident in saying that SDF's capabilities on this front are absolutely industry leading. And that's where I'll stop. But that's not me being critical of anyone else who's innovated in the space. It's important for that kind of stuff to happen, and it always pushes everyone forwards.
Awesome. Thank you, Tristan. Lukas, anything to add? I was just very helpfully informed by the chat. There is a sort by most upvoted in the Q&A, so I want to make sure that we get to some data.
Oh no, let's get there. We can talk about that, and hopefully we'll be able to share a lot more about SDF's sort of compiler technologies and where sort of the differentiation is and what it really allows us to do in the coming weeks, months, years. Yeah.
Fantastic. So the top two questions I think Tristan alluded to already in his talk about core and how we are thinking about all of this. So the next up is I think this was like when you were running the commands that were failing and catching them beforehand. But does this the avoiding hanging the warehouse also equate to cost savings, e.g. by not sending the compute compile to Snowflake?
Let's hope so. Yeah, it's a huge thing, right? Like you typically, especially with like CTs and chain CTs, you'll run one, you run another one, and then like the error happens on the third one. Like that's all wasted compute, wasted time. Ideally, you just want a compiler to validate that this thing is correct before you ship it up. That's the goal of SDF. So yes, 100%. There's measuring compute savings is such a fascinating like topic because there's so many different axes that you could measure on. But yes, I think just in terms of validating stuff before it ships to Snowflake, it is wild how much efficiency gains we've seen.
Great, glad to hear it. Yeah, I've been. I know Elias is in the chat, and he has been hammering home. SDF saves you time and money again and again. Okay, next up, a really good question on how complete will the dialect comprehension be? I know there's a lot of SQL dialects out there, and it is a large challenge to parse all of them. So this is from John, who is on Snowflake, but I think if we can talk in general to kind of dialect comprehension and how people should be thinking about that.
Yeah, so this is like an infinite question, because like how many databases are there and how many new databases are there every year? The way that SDF works is when comprehension isn't there, it acts like a faster DBT, right? It does the same sort of Jinja expansion, etc. So it always works like DBT if the comprehension is not there. This is also a really important thing. The second piece is the major dialects will be supported on day one. It's a really important thing. They're supported in SDF now. There's a question of like, my I'm trying to think of like some opaque database. There's some interesting questions like Mongo, right? Mongo is super popular. The Mongo dialect is like very loosely defined. I don't even know if Mongo has a really great definition for exactly what MongoDB dialect looks like. I think there was a question in the chat about Mongo specifically. So there are sort of there's time and effort involved in onboarding every new one, but it's not a crazy amount of time and it's not a crazy amount of effort. So I think for every dialect where there is enough interest, we will start adding them or providing ways to add those dialects. But I think that's very much a future question. What we're trying to do today is really make sure that the technology stacks integrate really well.
Great, makes sense. And definitely let us know which dialects you're interested in, what database you're using. We have a pretty good sense, but always great to hear from the community on this. Okay, quick one, but I think we've been talking about Rust a lot as the engine driving this, and so there's a question about how this will interface with the DBT capability to run Python models, and what this means for Python models.
Is another great question. One I was curious.
Lukas, do you want me to take that one, or do you want to take it?
Go for it. Take it for and then if I have anything to add.
Correct me if I am wrong about any of this, but I think that SDF is totally focused on the SQL experience and doesn't currently do work on the Python side of the house. But there are interesting applications for the Python world, especially when you get into Spark is a standard that is much newer than, for example, SQL, but it is going in that same direction, and you could imagine at some point in the future that there could be multiple standards that could be supported by a technology like what you've built at SDF. Is that a fair statement?
Yeah, absolutely. It's a different pipeline, but the goal would be to use the same intermediate representation that SDF uses today.
Yeah. So nothing currently to announce in terms of Python models with this news, but we're excited about the things that it gives us the ability to do over the long term.
Great. All right, a couple high engagement questions on linters, so I'll bundle these two together. Jacob asks, for the linter, can you set up custom rules similar to SQL Fluff, or is there an SDF standard?
There was an SDF standard, but that standard was to be very, very conformant with SQL Fluff. So we had the same names, we had aliases for SQL Fluff rules, and it didn't work with the .SQL Fluff configuration, but there's a very similar with rule portability from one to the other. So if you have a capitalization rule in SQL Fluff, you should be able to use that same capitalization rule in SDF. The difference is it runs much faster. I think I even have a public LinkedIn post from 3 months ago when we sort of announced the linter, that if you're if you have a very large warehouse, it's not like 10 times faster, it's like 500 times faster, which is very, very exciting. And the fact that it's integrated into the same engine, again, makes the developer experience a little bit easier. So I'm hoping that the sort of SQL fluff to new linter configuration migration is easy, and then the developer experience is so much better that it's just that it's an obvious thing to do.
Great. And this is probably in the category of things that they're still under active discussion, but we got a question from Jenna, very, very quick. It's lints ... and fix ? So I don't know if you want to say anything on that, or how you're thinking about that.
Sorry, could you ask that question one more time?
Lint and fix, with the idea being that we'd be able to apply those fixes for you.
Yes. So there are rules that are fixable, and then there are rules that are create ambiguous outcomes that are not automatically fixable, sort of per definition for what the rule is. For example, if you like disallow keywords, we don't know what you should use instead of the keyword. So that's obviously not fixable automatically, but anything where the state space is constrained enough that it can be fixed automatically is fixable automatically.
Great. Okay, we are about to run up on time. One more question, and I just have been waiting to ask you, Lukas, what's it like to start a company with your dad?
It's a great time. It's a really, really great time. Yeah, I've said this, I think to Tristan as well before. I think 5 years ago, 7 years ago, like it would never have been a possibility. But at this point, we've developed slightly different ways to think about things, and in part very similar ways to think about things. We work well together, don't have problems disagreeing with each other when that's the case, and don't have problems supporting each other when that needs to happen. So it's, I think, been one of the really, really validating parts of my career thus far. Highly recommend. Net Promoter Score, at the very top for starting a company with you.
It's super fun being in meetings with both of you. The dynamic is awesome, and everyone should hope to have the kind of father-son relationship that you two have. It's really cool. We have a couple follow-up things that we want to hit, but there's also a million questions that we haven't answered. Do we have instructions for folks, like where can they take those questions? I think, Jason, do you agree? Is DBT Slack in that channel? I forget the name of the channel. Is that the best place?
So we have a topic SDF channel on Slack. Please share your questions there. There's so much to discuss here. I think that this event has made it so clear that there's just a lot of conversations for us to have. Really appreciate everyone's enthusiasm. We're so excited to keep having these conversations with you, keep learning, and keep sharing what's getting built.
Yeah, and I will, maybe myself and Elias will hop in that channel and answer questions. So I looked at the most upvotes. There's a lot of stuff to still get into. So if you want to translate some of those questions to the community Slack, I will be there, and Elias will likely be there as well. And we're happy to answer any and everything that comes up.
Great. We will catch you there. And then, so I just wanted to close out. Thank everyone so much for joining. This was a really great event. Thanks to Tristan and Lukas for walking us through this, and some takeaways for you if you have enjoyed today's presentation. First of all, you can click the orange button on the top right-hand corner in Goldcast to get a one-on-one DBT Cloud demo. Also, if you want to know more about this, the best thing to do, many of the questions were around how this functionality will roll out, what it will look at like. The 2025 DBT Cloud Launch Showcase is coming up on March 19th. Register there today. It's going to be a great time. We're really looking forward to chatting more with you all then. And finally, feedback on today's session. We want to know if you enjoyed it, anything that could be better. So please let us know what you think in the survey that is getting sent in the chat. And just want to say thanks again to everyone for coming out. It was so fun to get to share the excitement with all of you. Really felt it in the chat and starting to see the unlocks happen for people about what this is going to drive and why there's like multiple levels of things where it's like, wow, wow, wow. So thank you all for being on this ride here with us.